All right, guys, this is worksheet 1. We're finishing this up. One B, we did not finish this yesterday. The very important thing from this slide that I'm going back to talk about one more time is domain. The domain of a function, okay, is restricted when there is a radical, like a square root or a fourth root. Whatever is underneath that must be greater than or equal to 0. If a function has a denominator with an x in it, whatever is in that denominator you set equal to 0. Otherwise, their domain is all real numbers. One more time, the domain of every function is all real numbers unless there's a radical with an x in it or a denominator with an x in it. Okay? That being said, we left off here with number 11, yes? Okay. Number 11, is this a function? You could graph it. Is there anything we're going to put in and we're going to get out 2 different answers? No. When you take the square root of something, as long as it's not the square root of an x, which this has an x in it, but it doesn't say like y squared equals x. It says y equals the square root of x, so there's only one primary root. A square root graph looks like this. Ours doesn't. It's actually going the other way because of the negatives, but it passes the vertical line test, okay? So it is a function. Then how do we find the domain? It has a radical, so what do we have to do? It has to be greater than or equal to 0. Remember, if there's a radical, what's underneath must be greater than or equal to 0. It can equal 0. Everybody all right with that part? Square root of 0 would just be 0. All right, so we're going to do negative 3x minus 2 has to be greater than or equal to 0. Then what happens? Add the 2. Whoops. And then? That's really messy. Let me rewrite that. When we divide it by a negative, we had to remember to flip the sign. Now, can you write that in interval notation, anybody? Okay. I want to show you the graph real quick. The square root of negative 3x minus 2 looks like this. You would struggle mightily to find that value, that negative 2/3, okay, from this graph. If I hit trace, it says there's nothing. If I arrow to the left until I get a value, does this say negative 2/3 right here? No. Okay. And it won't let you find a 0 because it never crosses the x-axis. So if you try, you get an error. Now watch it work. I lied. Sometimes I get, when I type numbers in, I get an error sometimes. I don't know how. Sometimes it finds the 0 when it doesn't cross. Anyway, if you did the 0, it would have worked, apparently. Maybe, depending how you put it in. But that value is where it starts, okay? So maybe you would have got lucky. Algebraically guaranteed here to get negative 2/3. What is the range? Do you remember range is the y value from the bottom to the top? It starts here at the y value of 0 and it goes up. Think about that. Things that come out of a square root have to be 0 or greater, right? Does that make sense? All right. I think that's one of the only ones I'm going to talk about, the range today. We good so far? All right, let's try. Is number 12 a function? We're going to talk later this chapter about parent functions. This is the parent function of this. Okay, then somehow it shifted to the right one and was stretched by 5, if you remember any of that business. Actually, it isn't to the right one and by 5 because it's on the y. But we'll talk about that later, much later. But this is the parent function, and what did we say? When y is squared, means this could have been, if I put in a 4, I could have got out a 2 for the y, right? 2 squared would be a next value of 4, and for negative 2 would also work, because you're squaring the y, so this is not a function. So therefore, we're not going to do domain or range. Okay, number 13. Most of you would look at that and go, I don't know if that's a function. You could graph it. It does some crazy business like this if you get an appropriate window. Do you remember those rational function things with asymptotes? Okay, we're going to hit those hard this year again. This one looks like this, so what do you think? Is it a function? Yeah, any vertical line, it won't hit anything here, but it won't cross it twice, right? So it does work as a function. You're fine, Sarah. Just throw it. All right. How do we decide what the domain is, though? Yes, it's all real numbers except those which make the denominator equal to 0. Good job. Can we find those? Okay. Are 3 and 5 the domain? Those are the exceptions, right? So can anybody tell me that in interval notation? That's a hot mess.
Negative infinity to 5.
Nope. Least.
Oh, 3.
Okay, everybody understands that even though 3 was written twice and 5 was written twice, the fact that it's with parentheses means it's not included in either one, right? It is a hot mess. A lot of work to say not 3 or 5. All right, I'm not going to talk about range on that one. It's messy. And I don't even talk about it when we do those in class, when we do that chapter. We don't use range much. All right. Let me see if I can make these a little bit bigger. You don't have these, so just talk me through these. If you want to make extra notes somewhere, you're welcome to. 2 of these are things we haven't talked about before. The first one is one you should be able to get. Everything works except what? Everybody okay with that one? Okay. This is a little bit messier, actually a lot messier. What's going on here? When you have a radical, how do you decide the domain? Okay, what's underneath has to be greater than or equal to 0. You could square root, but it gets messy and confusing. I'm going to factor this. What are the 2 places that this hits 0 at? Okay. So -2 and +2. Now I need to decide, is this greater than 0 in between or outside of those? What's the value in here? In here would be like a 0, right? Does a 0 make this true? 0 squared minus 4 greater than 0? -4 is not greater than 0, right? If I put in a -5 and squared, I get 25 minus 4 is 21 is greater than 0. I just picked something down here. If I put in a 4, 16 minus 4 is 12, something up here would work. Okay, so how would I say that in interval notation, that values outside of those work? It is inclusive because it was or equal to here. Okay, let me show you the graph of that so that that makes a little bit of sense to you. That makes sense? The range would be 0 to infinity. Okay. Because when you square it, anything will become positive. So almost all the numbers work. But when you subtract 4, then you have to be careful that you're not falling below 0. All right. Last one. This one is got a little bit of a trick to it as well. What's going on here? It's a radical and in the denominator. Normally what's underneath the radical has to be greater than or equal to 0, but can it equal 0 if it's in the denominator? No. So we just have to say 2x plus 6 is greater than 0. X has to be greater than -3. Everybody okay? I didn't bother to write the interval notation on the first one. Any questions? Those were just some extra examples, all right? All right, we are going to switch over to worksheet 2 and talk about piecewise functions. I know this is kind of painful. I need you to try to stay awake and focused. The first one isn't too bad, all right? It says... Let me go back to yesterday's real quick. When we did a piecewise function, or when we looked at one, we didn't write one yesterday, but here was one. There were two parts to it. There were the rules over here, yes? And then there was this definition of where the rules were true, yes? Okay, so those are the two things we're looking for when we do this question. A restaurant patron has decided to leave a 15% tip for meals costing up to $40, an 18% tip for meals costing at least $40 but less than $100, and a 20% tip for meals costing $100 or more. Write a piecewise function to describe the total amount T, and I'm going to go with the total of the tip. It wouldn't make, we'd just have to add on the cost of the meal. But we're just going to find the tip that the patron will pay in terms of the cost of the meal C. Anybody tell me anything we're going to write down? It's wide open right now. Vespa? Okay. If we were doing the total cost, it would be the cost plus 15% of the cost for the tip. I think we're just going to do the tip, so we'll go with 15% of the cost is going to be their tip, okay? She's absolutely right. If we did the total amount spent, it would be this. But in the other two classes today, we just did it as the tip, okay? So 15% of the total cost of the meal is the tip. If what is true? Okay, is it equal to? It says up to $40, okay? This one actually says at least 40, which would mean that one's going to include the 40. All right, a little trickiness. So the next one is at least 40 but less than 100. Anybody know how to write that?
40 is less than 40, which is greater than 40.
Okay, I heard a less than or equal to. Yes, it's a sandwich between 40 and 100. At least means including 40, okay? If you're at least 40 years old, you get in for free. I think that should be the case. So that would include 40, okay? But less than 100. Everybody okay? Anybody tell me the rule that went with that? Yep, 0.18 or 0.18c. And everybody raise your hand. Got the last one? Somebody's got this. Knock it out of the park. Jared. Or just 0.2. Yep, either one is fine. Costing $100 or more. Yep. Guys, I don't care if you use X, but they said T of C, so we use C everywhere. Now, that one was pretty straightforward. Do you think you could have done that one on a test or quiz? Maybe? That one's not too bad, right?
I mean, now I couldn't before this.
Yeah, but it's, yeah. That's not too bad. Okay. What was the relevant domain on that question? We talked about this before. We talked about like an implied domain when we threw up the ball. It couldn't go underground. It couldn't have negative time. The same here. You can't have negative cost of a meal, right? The upper bound. Yeah. The upper bound, I don't know. It depends how fancy the restaurant is. It could go really high or how many people you're feeding, right? A relevant domain just means consider the function what it's talking about, okay? This question, can anybody tell me the domain of this? If the rules are also, you don't have this one on your worksheet. It just leads into the next one nicely, so I want to talk about it real quick. The speed of a vehicle in miles per hour can be represented by the following piecewise function when t is the time in seconds, even though the speed is in miles per hour. Find the speed of the vehicle at each indicated time. What is the domain? Right here. Everybody okay? 0 to 250? Because it went 0 to 15, 15 to 240, 240 to 250, yes? And the 240 was included in this one, and the 15 was included in this one. We okay? We're going to eventually have to talk about whether this is a continuous function or not.
Yeah, I was going to say, wouldn't it be infinity because it's just greater
Nope.
than 250?
This says less. T is less than or equal to 250. Okay? All right. Help me find these values real quick. What is the speed at 5? That's this rule, so we get 20 miles an hour. Okay, what is the speed at 15? Now, does it matter which rule? It says to put it in here, right, because it's or equal to, but 4 times 15 is 60. Would that be continuous? Because going down to this one, it stays at 60. That's going to be a question we deal with tomorrow. Is this function continuous? At 15, it is continuous because it works here and here. They overlap. All right, before we go to 245, can we do 240 real quick? Here, I would put 240 in this one. Can somebody type what's negative 6 times 240 plus 1500? It's 60, right? So, is this continuous at 240? It was 60, almost up to 240, and then at 240 we put it in and we also got 60, yes? So it is continuous there as well. We're going to graph this in 1 second, absolutely. And 245, can anybody put 245 in? Negative 6 times 245 plus 1500? 30 miles an hour. Okay, to help me graph it, I need one more point. I need 250, guys. Can you do 250? When you put in a 250, you get out a what? 0. Okay. I want to graph this, so I'm just going to graph the endpoints because they're all linear, yes? These are all lines, guys? So it started at 0. If you put in a 0, you get out a 0. Then it went to 4 what? If we put in a 4, we would get out a... no, if we put in a 15, we'd get out a 60. If I spoke like I was thinking. T went up to 15, right? And it went up to 60. Sorry. So at 15, it's at 60. Then what happens? It stays at 60 all the way out to what? Until the time hits 240. And then what starts to happen? It's at 245, we were at 30, right? And at 250, we were at... you told me 250 gave you 0, right? Does this make sense? The car accelerated for 15 seconds, drove 60 miles an hour for almost 6 minutes, just short of 6 minutes. After it got up to speed, it went 6 minutes. And then it decelerated and went back to 0. Okay? I want to tie that together because we're going to do the same thing. This question does not talk about only speed and time. It actually talks about distance covered. It says, in a triathlon, athletes swim 2.4 miles, then bike 112 miles, and finally run 26.2 miles, and then they drop dead. Yikes. Jesse's average rate for each leg of the triathlon is shown. So his rate for swimming is 4 miles an hour, for biking is 20 miles an hour, and running is 6 miles an hour. We have to write a piecewise function that shows his distance covered, okay? How much total distance does he cover? Can we figure that out right now? He swims, he bikes, and he runs. You add that up? Okay. So that's our total distance covered. And we're supposed to write a piecewise function that deals with time. Do we know anything about time right now? We know distance and we know rate, and we're looking for, does that sound vaguely familiar? Yeah. Distance equals rate times time. How could we rearrange that to get time? Okay, so swimming, what was his distance? Stay with me here, guys. 2.4 miles he swam at 4 miles per hour is what? 0.6 hours. Okay, then we're switching to blue. Biking, 112 miles, right? 112 miles at 20 miles per hour. Somebody divide that. They do. It's the longest part here, I think. It's 6 point something, isn't it? Somebody dividing 112 divided by 20? 5.6 hours. And then, fresh as can be, he's going to start a marathon. 26.2 divided by 6 miles per hour. 4 point something. 4.38 or 4.4, roughly. It says round to the nearest tenth down here. Is that right? Did I hear everybody right? Okay. Let's find his total time just for fun. We're going to need it anyway. We have 0.6, 5.6, and 4.4. Isn't it 10.6? Yeah, I'm with you. They really do this, the Ironman triathlon, and they probably run them other places too, but I knew they do one in Hawaii. If I had to go 26.2 miles, it would take a lot longer than 4 hours.
Sunday, they were at 31.
Okay, guys. The domain, what is the domain? Domain is time.
0 to 10.6.
Okay? So part B was a piece of cake. Okay. To help us with part A, I'm going to suggest that we plot some ordered pairs. Okay. He starts 0 distance, 0 hours in. What is the next point we know? At how many hours in, he's how far away? At 0.6 hours in, he's 2.4 miles away. Is that right? I should have done that in what color? Does anybody remember what color I did that one in? Red for the first one? Okay. Red for biking.
Improvise.
Okay. Then, now this is where it gets a little more confusing. He goes another 5.6. But we have to add that on to this, right? For our ordered pair, the total time he's been out and doing this is 6.2. And how much distance has he covered?
114.4.
Yes, 114.4, because he went, this little stretch, was that blue, guys? This little stretch went up another 112, added on to the 2.4, which puts us at 114.4, and it went over 5.6, was that right? And we were already over 0.6, so we wound up at 6.2. Did I get that right? And it should have a different slope than the first one. It doesn't look like it does. I did a bad job of drawing it. I'm going to do this one a little flatter because I'm thinking he's slowing down. How far did he go by the end? We figured out both of the end points already. What did we figure out? Took how long total? 10.6, and he went a total of 140 point something? 140.6 miles? Okay. All right. Now we're supposed to write the equations. This, yes, I think it's going to be easier now that we have this. What does this piece have for values of t, guys? Went from 0 to?
X is greater than 0 and less than 0.
Okay. And you can include both ends, one end, it really doesn't matter because the next one picks up at exactly the same spot. Do you want to just do all those? What's the next one? The next one picks up at 0.6 and goes how far?
All the way to
6.2. All right, and the next one starts at 6.2. Different color. 6.2 is less than or equal to t is less than or equal to 10.6. Now, it wouldn't matter which one you included the 6.2 on because they're equivalent, and it wouldn't matter which one you included the 0.6 on. Normally they don't put it or equal to on both of them. They put it on one or the other. Okay? I don't care. Now, the equations of each of these pieces is what? It's a line, right? All right, I'm going to go kind of quick because I know you're losing you here. Everybody awake? This piece goes from 0, 0 to 0.6, 2.4, yes? So the slope of that is 2.4 minus 0 over 0.6 minus 0, which is 4. Something about that first piece and the number 4.
the speed.
It's a rate? Really? Distance per time? Change in y, change in x is a slope? Yes?
Yeah.
So this was 4 times the time. And it went through the origin, so it'd just be plus 0, right? Sarah, did you have a question? Did I mess something up, or you guys got a question? You all right? We good? Okay. The next chunk, unfortunately, doesn't go through the origin, right? Okay. But we know the slope. I'll write the slope down just to make you feel better. But guess what it is? It's 20 because it's this rate. All right. Now, I want to talk about what happens. If I use this point right here and this slope, and I do point slope, okay. If I were to add the 2.4 onto the end, I'm not going to bother to distribute, guys. Because what this really says, look at this equation. We're going to talk about parent functions soon. Doesn't this mean it shifted to the right 0.6? Remember that when you had the parabola thing? And up 2.4. Is that what we did? We took this blue line and we shifted it to the right 0.6 and up 2.4. All right, so what about this green chunk? Its slope is 6, yes? And it went to the right, how far before we started that? 6.2, and it went up 114.4, and I don't have room to write that in there. I don't know if I can slide this whole thing over. Oh, I love it when that works. Okay. So, if I told you there's not one of those on the next test, that would be okay?
Yeah. Too bad there is.
No, there's not. We will do more of those, and maybe eventually one could be on a test, but that's pretty tricky stuff, right? There's a lot of parts there. All right. This concept is so much easier, you're just going to laugh. You're going to say, huh, this was the easiest day ever. Huh. Guys, we're going to do rate of change. Rate of change is just slope. Wake up. Everybody awake?
Yeah.
Do we need to pause and do candy?
Yes.
Okay, you literally got... All right, guys, we're talking fast here. The rate of change is really just the slope. Okay, so if you have a function, f of x, and you put in an a, you would get out f of a, yes?
Yes.
We call it y, but f of a. If you put in a b, you would get out whatever f of b is. The rate of change is the slope. Does that look familiar? F of b minus f of a over b minus a. Okay. It makes it look awful. Here we're going to do this question. It says find the rate of change for this question. This is what I'm worried about right here, this rate of change. Okay? For this function, if I put in a 3, I go 3 times 3 minus 4 and get out a 5, yes? If I put in an 8, I go 3 times 8 minus 4 is 20. If I want the rate of change, I get 15 over 5, which is 3. Do you see that anywhere in that question? This is a line, right? The rate of change is the slope on the whole line. Any 2 points I picked, the slope should be 3. Okay? That is not true. That only works for lines. That only works for lines. This one's not a line, right? Okay. So when we put in a 2, we get out 2 squared plus 6 times 2 minus 10. I need help. Is that right? Okay. What if we put in a 4?
30.
Okay. And then the slope?
2 over
Miranda? Change in y over change in x?
I did it again. I swear to God.
I got 12, yes?
I knew it was preschool.
Okay. 12, we're good? Okay. That is not a constant. If we picked points 0 and 1, or points 1 and 22, or points 7 and 19, you'd get totally different answers along the way. There is not a constant rate of change along the curve of a parabola. All right, this is just a pretty picture that shows what they're doing is talking about even though you have a curve, you can find the estimate, you find the rate of change by drawing a line between 2 points and finding the slope. All right. Which is greater, the average rate of change between 0 and 1 or between 4 and 5 on this function? So if I put in a 0, I square it, I get out a... I put in a 1, I square it, I get out a... The slope or rate of change between those is 1. 1 minus 0 over 1 minus 0. Okay, what if I put a 4 in and square it? And a 5 in and square it? Okay, 25 minus 16 over 5 minus 4 is? The rate of change here is 9. Very different, okay? Picture a parabola. Between 0 and 1, it went over 1 and up 1, yes? The plain little parabola. But the steeper, the further you go up, the steeper, yes? Okay, that's all it's telling us. All right, which of these functions has the average rate of change? Oh, which has the greatest average rate of change between 2 and 3? Okay, if I put in a 2 to f, f is just linear, yes? Put in a 2, I get out a 2. I put in a 3, I get out 3, and the slope is 1. Okay, I'm going to do this one in red. I'm going to square it. So 2 squared is 4, 3 squared is 9. What is that slope? Right, 9 minus 4 is 5. 3 minus 2 is still just 1, yes? Okay, what about cubic? I'll slow down a little bit. 2 cubed is, 2 times 2 times 2 is? 3 times 3 times 3. 27 minus 8. Okay, so which had the greatest rate of change? The cubic, right? H of x equals x cubed had by far the greatest rate of change between 2 and 3. They would all be the same between 0 and 1. 0, 0, 1, 1. 1 squared is still 1, right? 1 cubed is still 1. So they were all equivalent rate of change between 0 and 1. All right, this is a calculus problem. We got time. Relax. I need somebody to be typing, okay? We got to square all these numbers here. When I put in a 1, I squared and I get out a 1. When I put in a 1.1, I squared and I get out what? Thank you. We're going to go back and find the slope in a minute. I put in a 1, I get out a 1. What do I get if I put in a 1.01 and square it?
1.0201.
Okay. Part C, I put in a 1, I get out a 1, because it said squared up here. 1.001 becomes 002. Okay. Now we have to find the slopes. I vote we just let someone subtract on the calculator for us. 1.21 minus 1 would be 0.21. 1.1 minus 1 would be 0.1, which is 2.1. The second one here, 1.0201 minus 1 would just be 0.0201. 1.01 divided by 1 would be 0.01. Somebody help me. 0.0201 divided by 0.01. I think it's 2.01, isn't it? Okay. This would be 0.002001 over 0.001. Okay. Here's the question. What did we change every time? We moved B. A stayed at 1, but B was at 1.1, then 1.01, then 1.001. B was getting closer and closer to 1. Everybody see that? To the A, yes, but to 1. What happens to the outcome? The rate of change changed from 2.1 to 2.01 to 2.001. That's getting closer and closer to 2. So what value does the average rate of change appear to be approaching as the value of B gets close to 1? It's approaching 2. 2.1 is 2 and 1/10, 2 and 100th, 2 and 1,000th. It's getting tinier and tinier, much closer to 2. This is the foundation of finding a limit in calculus. What we found is called the instantaneous rate of change, and it has enormous implications in calculus, it says, okay? Please note that your homework, the directions, it says here to ignore the directions in the book and find the average rate of change from x equals 1 to x equals 3 for these questions. You do not do what it says in the directions for those.